Welcome back, everybody. In this video, I want to talk more about absolute value. I know we've seen it a little bit already, but I just want to go into a couple more complicated examples and some additional properties of it. So the absolute value of a number A, which is written with these two vertical lines around it, so this is the symbol for absolute value, is the distance from A to 0 on the real number line. So for instance, just a super quick review, something like the absolute value of -3, what I could do to find it is I would look at that number line, 1, 2, here would be -3, and I'm looking at the distance. So if I were to count up to 0, I would go 1, 2, 3 positions. So our distance is just 3. And what you see is that your distance is always positive. So the absolute value of a number, unless of course that number is 0, is going to be positive. So the absolute value of 2, for instance, is just 2, because again, 2 is 2 spots from 0. And like I said, the only exception would be if you have the absolute value of 0, then that is just 0. But otherwise, your distance is always positive. So we've seen this already, and let's look at a couple more complicated examples and make this a little bit more formal. So here is another formal definition for the absolute value. So the absolute value of a variable x is equal to x if x is greater than or equal to 0, or -x if x is less than 0. So what does this mean? It's actually the same thing I just told you. It's just, again, a little bit more formalized here. So notice that if the original number is positive, or 0, so 0 or greater, then the answer is just that same number that was inside. And that's what you're having in this first row. So if your x value is already positive or 0, then you don't have to do anything. The absolute value of that is just that number. If the original x value, though, is less than 0, so if the original value is negative, then what you're doing is you're taking the opposite of that number. So negatives also mean opposites. So for instance, if my value is -3, notice that I'm taking the opposite for my answer. So that's what this is saying. It's just a little bit more formalized here. So let's look at a couple more examples. Again, a little bit more complicated this time. Let's get a different color. So we're going to rewrite each expression without the absolute value bars. And for the first one we're looking at is the absolute value of the square root of 3 minus 1. Now, you could obviously get the decimal approximation using your calculator here, but that's not really what they want you to do. They really want you to just leave the expression, but remove the absolute value bars. So to do that, what's going to happen is we do need to know if the value inside the absolute value is positive or negative. So if the inside value, so basically the inside expression is positive, leave it alone. And if the inside expression is negative, we're going to use its opposite. Okay, so here I need to know, first of all, is this positive or negative? So I'm going to take out my calculator here. And if I look at the square root of 3, I get 1.73. And if I subtract that with 1, I do get a positive answer. So the inside here is positive if I were to simplify it. And because it's positive, then what's going to happen is we're just going to leave the answer absolutely the same. And that's it. Now, again, if you want to use your calculator, you could simplify this and get an approximate answer, but the question doesn't ask us to do that. It just wants us to find a way to remove those absolute value signs. Let's do another one. So for the second one, the absolute value of 2 minus pi. So again, your calculator should have these symbols on it. If not, pi is about 3.14. So my calculator has that pi symbol right there, and it's in yellow, so I'm going to match it with my yellow key. And again, if you don't have it, you can just approximate it. That's all you need here is to figure out if our value is positive or negative. So we do see that we have 3.14. So when I do 2 minus 3.14, I get a negative value. So this on the inside is actually negative. So if I want to rewrite this expression, and again, I don't want the decimal answer because that would be pretty easy to figure out. I just want to rewrite the expression. I know the inside value is negative. So when the inside value is negative, we're going to use the opposite of the expression. So instead of just leaving it as it was, I'm going to take it and I'm going to make it its opposite. Okay, so that negative is another way to think about just as opposite. Okay, and this actually isn't incorrect, but we could simplify it a little bit more. So I could distribute that negative through, and I get negative 2 plus pi. And a lot of times we do like to write the pi first, or not even the pi first, the positive value first. So this is correct, or if you want, adding a negative is the same as subtracting 2. So that would be the most simplest way that we could write that final result. And one more example of this type. So again, this one's a little bit harder. We're simplifying here. And I'm noticing that, again, what I want to do is get rid of those absolute value bars. So I'm told here that the x value is less than 0, right? So the inside of our absolute value here is going to be negative. So if the inside is negative, I'm going to actually use the opposite. So what I'm going to get here, instead of using just x in the top, I need to use the opposite, so negative x. And then the denominator does not have an absolute value, so I'm just rewriting it. I'm only simplifying the absolute value part. Now that the absolute value is gone, I actually can simplify further. So you cannot simplify or divide this out while it's still in the absolute value. So now I can. So here, this right here is just the value 1, right? Those x's are going to cancel out. So I'm left with just negative 1. As my final result. Okay, so just a few more complicated examples with absolute value. I do want to talk about a couple of applications and also properties here. Okay, so I'm still in the same lecture notes. I'm just kind of adding a little subtitle here for my properties. So for these properties, we're going to let A and B be real numbers. Okay, we have the following. So the first property is that the absolute value of a number is always positive or 0, right? So 0 at the smallest, but it is always positive. And we've talked about that. So I'm just going to write that in words. So the absolute value of a number is 0 or greater. The other thing is that if you have the same value, but one's positive or negative, and we take the absolute value, it's going to give the same result. So for example, right, if I have the absolute value of negative 5, that would be 5. And the absolute value of 5 is also 5. So if you have the same number, but they're on opposite sides of the number line, you're still going to get the same answer. And that's really what this rule says here. A third property is that the original number is always less than or equal to the absolute value. So for instance, let's say our original number was negative 5. So if A was negative 5 here, then what this would say is that negative 5 is less than or equal to the absolute value of negative 5, which is true. right? The absolute value of negative 5 is 5. So it's just showing that the original value is either smaller or it could be the same. If their value was positive, then they'd end up being the same. Okay. Now this one could be helpful. So the absolute value of A times B is equal to the absolute value of A multiplied by the absolute value of B. And again, this can just help us simplify a little bit. So if you're multiplying two things together, we actually can sort of separate out that absolute value. That does not work for addition and subtraction. So just be really careful. This is particular to multiplication. And then the same thing is going to be true for division. And of course, just make sure that your denominator is not 0 there. Okay. Now, I do want to point out that this is actually different than our last example. You may be saying, well, this was the same thing, right? But it wasn't. In our last example here, the absolute value was only in the numerator. It was not over the entire fraction. So notice the difference. If it's over the entire fraction, then you can separate it out. But here it was not. It was just in the numerator. Okay. And then the last property . So you can't just separate it out for addition and subtraction. It doesn't quite work that way, but we do have an inequality that we can do. And the absolute value of A plus B is always less than or equal to the absolute value of A plus the absolute value of B. It doesn't mean they're equal. So like I said here, these tricks only work for multiplication and division. You do not necessarily get equality for adding and subtracting. But for addition, we do get that it is less than or equal to. So we have an upper bound. And this is actually called the triangle inequality. Now, I don't know how often you'll end up using any of these properties of absolute values. They're not used overly much, if I'm being honest. We use them occasionally here or there, but they tend not to be a huge part, but they're still good to know. So if you come across some little examples, you know, particularly something like the triangle inequality down the road, you know, you have an upper bound, but not an equality. The more common ones, I think, are the beginning ones, just remembering that your distance is always 0 or greater, and that if you have the same number on opposite sides of the real number line, it's the same distance. So those are probably the more common ones, but some of the bottom ones can be helpful as well. Now, there is a really helpful application that I want to talk about here, and that is the distance between 2 points on a number line. So this is going to be an application. And this is the distance between 2 points on a number line. And I want to be clear here, it's a one-dimensional number line. When we get to 2 dimensions, and we'll see this in the 162 course, the distance formula gets quite complicated because now you're going to 2 dimensions when you have the full XY plane. So there are different distance formulas depending on the examples you're looking at and how many dimensions you're in, how many variables you have, and things like that. So this is our most basic distance formula, really just for one dimension. So you're just on a single number line. This is not where we have the full rectangular plane here. But the distance is pretty simple, and it's just given by the following formula. And all you do is take A minus B, or you can take B minus A and just take the absolute value. So it's pretty straightforward. So let's do an example. Okay. So find the distance between -5 and 3 on the real number line. So using the formulas there, you're just going to subtract these values and take the absolute value. And it doesn't matter the order you do it in. So for instance, let's say I take the -5 first and then subtract 3. Well, -5 minus 3 is -8. and the absolute value of that is 8. If I did it the other way and did the 3 first, and then I subtract the -5, again, just be careful, you're subtracting a negative. Well, these two negatives will cancel out and become positive, and then the absolute value of +8 is also 8. So you have that same distance there. The other way you can do it, of course, is visually. So if I were to draw a number line, 1, 2, 3. So here's 3, 1, 2, 3, 4, 5. There's -5. And I were to actually count the spaces, 1, 2, 3, 4, 5, 6, 7, 8. We do see that there are 8 spaces apart. So you could also do it visually and count as well. But this can be a nice quick formula. And it does work whether your A and B are positive, both negative, one of each, you'll still get the right answer. So this is a nice application of absolute value when we're looking at the distance between values, again, in that one dimension space.